Hi, this is Miss Webb, and I'm using a different software package to record this video, and let's see how it goes. I'm not real confident, but we'll see how it goes. This is factoring by grouping. So I'm going to teach you how to factor by grouping. We're going to do it, you normally do it with you have a 4-term polynomial. You cannot play the game, two numbers that multiply to the back number and who add or subtract to the middle term when you have 4 terms. That's why I mean you can't play that game when you have a 4-term polynomial. So let me show you what you can do. So if you have a 4-term polynomial, and here's what it looks like. And you see it's the 3rd degree, but it's got 1, 2, 3, 4 terms. Then what you're going to do is you're going to group the first 2 terms and the last 2 terms. Now, what I usually say is on the here is like usually that's what you do. There might be a case sometime when I show you this and you can't find a greatest common factor between the first 2 terms and the last 2 terms, and in that case you might want to swap these 2 terms. But let's just go with the way it's normally done. I'm going to group them together. Notice that I have 4x cubed plus 8x squared. I put a plus sign here. And the negative I'm putting with the 5x. So I haven't changed this this equation. Well, it's not an equation. I haven't changed this polynomial at all when I come down here. I'm just grouping it by, I'm putting parentheses around it. Okay? Now, after you come up with your 2 groups, this is the first one, that's the second one, you're going to find the greatest common factor of the first group. I'm going to go get my pen, or maybe I'll get my highlighter so you can see it. So I'm going to look at my first group here. Okay? And you want to find the greatest common factor of this group. Well, this has a 2 and a 2. This has a 2, a 2, and a 2. So I'm going to take out 2 2's, which is 4. Notice both of them have 2 x's. This one has 3, but it's got, the greatest common factor is 4x squared. They each have a 4 in common. They both have an x squared. So we've been talking about greatest common factors. You want to take out the greatest common factor, and I'm going to come put it right here. Okay? Now if I factor it out, then remember I have to be able to say, okay, 4x squared times what would give me 4x cubed? Well, if I just multiplied it times x, I get 4x cubed. 4x squared times what gives me 8x squared? That would be 4 times just a 2, because I already have the x squared. Okay, now I'm going to come over and I'm going to look at the second group over here. Now in this one, I'm going to take out a negative 5. So if I take out a negative 5, because this has a 5 and a 2 in it, I can't take out a negative 5x because this 10 doesn't have an x in it. So if I take out a negative 5, I have to go, okay, negative 5 times what would give me negative 5x squared? Bx. Negative 5 times what would give me the negative 10? It would be a positive 2, because negative times a positive would give me a negative. Okay, now notice down here, these are underlined. You can only do this if those things that are in parentheses are exactly the same. If they're exactly the same, then you can come down here and I can say, well, 4x squared minus 5 times x plus 2. Those are equivalent. Okay, so really what you've done here is you've double distributed. You're going to distribute the 4x squared to both of those. You're going to distribute the negative 5 to both of those. When you come down here, when you multiply 2 binomials, don't we talk about double distributing? Okay, that's why that works. Okay, let's try another one. Okay, factoring a 4-term polynomial. Here it is. It's got 1, 2, 3, 4 terms. I can't play the game with this one. So I'm going to come over here and I'm going to get my other pen out. And so it's a little bit easier to write on. Let me make sure it's open. Okay, so if I come over here and I'm going to say, okay, 5x to the 4th plus 20x cubed plus 6x plus 24. I just grouped them. I didn't change the value of the expression though. My greatest common factor here, well, they both have a 5. Both have a 5, and they both have 3 x's. They don't both have 4 x's, only this one does. If I come over here, they both have a 6. I can divide 24 by 6 evenly, and that's it. They don't share anything else. They don't share that x. So I come over here, I put this 5x cubed here, put this 6 there. Okay, what would I have to multiply 5x cubed by to get 5x to the 4th? Well, times x. What would I multiply 5x cubed by to get to 20x cubed? Let's see, the 4 would give me 20, and I already have the x cubed, so I'm good. Over here, what would I multiply 6 by to get 6x? Just x. What would I multiply 6 by to get to 24? 4. That allows me to come down here and say 5x cubed plus 6. Okay. Now this is going to come in really handy later on, especially in Algebra 2. Okay. Now the other thing is whenever you're factoring, you may always have to factor the greatest common factor out first. Otherwise you're going to do a whole bunch of work. Okay, when I look at this 45, okay, it has, let's see, 9 times 5. Ooh, I'm pretty happy there. A 9 and a 5. And I know 9 is a 3 and a 3. Okay, this breaks down to the factors of 3 and 3. This is 3 times 10, which is 5 times 2. And this is 3 times 2. So what do they all have in common? They all have a 3 in common. That's how I can determine the greatest common factor. So I'm going to do that first. And here I'm just going to get rid of everything off the page. And I'm going to come over here and I'm going to take a 3 out. Now, can I take an m out? I got 4 of them there, 3 of them there, 2 of them there, and I have an m. So I could take out a 3m. Okay, 3 times what equals 3m, and this time it's going to be a cubed. Minus 3m squared plus 10m minus 2. Okay, now I'm going to group the first 2 terms. Now, remember, I'm going to leave this 3m out here because you don't ever want to forget that at the end. You always want to put that 3m because you want an equivalent expression to this guy up here. Okay. But we're just going to work on factoring this part here, and I'm going to group the first 2. Group the back 2. I'm going to find the greatest common factor of this one here. Greatest common factor here would be a 2. So if I put this out here, if I factor it out, what would I have to do to get that 15? 5m minus 1. Over here, if I take the 2 out, I just get 5m minus 1. Are these the same? Yes. Okay, what happens if I get to this point and it's no? Then you can say it is not factorable. And we haven't talked that much about that, but there are times when things are not factorable. Okay, and we're going to talk about what do you do when it's not factorable in some future lessons. Okay, But for now, hopefully, if you can underline these two guys, then you can come down here and say, well, that's the same thing as 3m squared plus 2 times 5m minus 1, because I'm really going to double distribute those. Okay. Okay, now this idea of this one again, here we go. Can you factor a trinomial by grouping? And in this case, I'm going to come up here and I'm going to fill in, I don't have, it's not 4 terms, but what I would fill in here, let me get my pen. It's not a pen yet. Okay. I'm going to fill in something here and here, and I'm going to play the game. If I do 6 times 12, though, the product is 12. And now I'm going to find two numbers that add, because that's a plus sign, to 7. Okay, 1 and 12 will not work. That's 13. 2 and 6 will not work. That's 8. But 3 and 4 will work. That is 7. So I'm going to come down here and I'm going to say plus 3x and 4x. Do you see how I haven't changed the value of the expression? 6x squared plus 3x plus 4x. Let's put a plus there. Plus 2 is the same thing as what I started with. I just kind of grouped these a little bit different. I broke them apart. So when I come down here, I'm going to find the greatest common factor here would be a 3x. Greatest common factor here would be just a 2. This one doesn't have an x, so I can't include it. So if I put a 3x here, and I said 3x times what gives me 6x squared? That'd be 2x plus 3x times what gives me 3x? 1. Now I'm going to come put a 2 here. I'm going to say 2 times what gives me 4x? Well, 2x. 2 times what gives me 2? 1. If these are exactly the same, then I can go to this right here and say 3x plus 2 times 2x plus 1, and I factored it. I think I have one more example. Let's go look. Okay, here's another one. 3x squared minus 10x plus 8. I need to look at the product of 3 and 8 for 24. And I'm looking for two numbers that multiply to 24, but who add to 10. But notice they're going to add to a negative 10. So I would say, well, 1 and 24, that difference is 23. That's not going to work. 2 and 12. Oops, 12. That difference will work. That's a 10. And for that to work, this would have to be a negative and this would have to be a positive. So I'm going to come down here, and normally you would think, oh, okay, I'll do a plus 2x, okay, and a plus, put my plus there, 10x. But I'm going to have a problem here. Let's fix this real quick. I'm going to have a problem here because the 2x and the 3x squared, they're not going to have anything in common. Okay. Let's go look. Let's see. You know how sometimes I said it, you might want to put the 10 there and the 2 there. Let's see if it works. Remember, I'm looking to see if they're exactly the same. So if I have, here's my 3x squared plus 2x plus 10x, and I try to take the GCF out of this one, the only GCF is x. You don't have anything else. Over here, the GCF you have here is a 2. Let's see if that works. I'm going to put an x here, 2 there. X times what gives me 3x squared? 3x plus 2. Now I have 2 times what? Well, that would give me a 5x plus 4. Okay, are these guys exactly the same? No. So that does not work. Let's see if we can move it around a little bit and see if we get a difference. Okay, let's see if we can try this. Just to make sure. Let's move the 10x and the 2x. Let's move the 10x here and the 2x here and see if it helps. GCF here is just an x. That's just a 2. So I would take out a x here. Now I'd get 3x plus 10, a 2 here, and I'd get x plus 4. Okay, this is one of those, it's not factorable, because these do not equal each other. So that's one of those where you would stop and say, okay, can't do it. It's not going to work. Okay, let's look at another one. Nope, that was my last example. So the examples I gave you in your homework are all when you have that 4-term polynomial and you're trying to factor it by grouping. So let's see if you can do those. Thanks.